right, so you had a chance to guess and see as just a sort of intuitive feel how motion works on a graph. If you're far from it, then you're farther from the axis, from this detector. If you start off close, you're going to be down here towards this area. And as time marches on, you're going to move closer or farther away. Now what I want to do is get a little analytical. I want to get to be, what does that mean? We said already that if some line is flat, that has zero change in position over time or zero speed. But let's just take this and slowly raise it to the roof and see what happens if we can get an idea of what that speed is. I'll hit the play button. We'll get a little start here. Then I'll start to move it up. Nice even speed as best I can. And we're going to get a little bit of a run here. As a matter of fact, if I touch that, I can see that at this point I was 3.2 seconds and I was 1.8 meter from the roof. Let's go over here, and I'm going to put a second point on there. Now it's 6.9 seconds and I am 0.73 meters, so I am closer to the roof. If I want to find out what that speed is, what I can do is I can go through and I can figure out what the change in the distance is between these two in that time period. Let's see if I can make this work. I want to know what that speed is. Oh, that's not going to come through. What that velocity is, I'll write it over here. I think you can see this. This velocity is going to be the change in that position in that same amount of time. So what is that difference? I can look at the distance here, 1.8 minus 0.73, and that difference in position is roughly 1.1. Okay? And the time from 3.2 to 6.9 is roughly 3.7 seconds. So when I divide these two, this comes out roughly to be 1/3, 1/4, so somewhere about 0.28 meters per second. If I had my calculator, I might be a little bit different. But I've taken the difference in the distance, I've gotten closer by 1.1 meters over that time, and that's how I calculate the velocity. So we'll see the velocity is just the change in position over time. Let's do one last little experiment in terms of calculations. I've walked towards that. Now let me go away a little different kind of speed. I'll start high and I'll work my way lower, and I'll go at a different rate. And we'll see if we can do the same thing. Okay? That is a much faster motion, and we'll see if that comes out to be faster on the board. I'll take a look at this position here. Okay? That's 1.9 meters, sorry, 0.7 meters roughly at 1.9 seconds, and then let's go up here where it's still fairly similar motion. Oh, come on. Okay, now I have 2 times. Great, that's 1 second apart. That's perfect. So let's see if that velocity is more than the first one we did. This is the velocity at the second position. The difference in here is the difference in meters. Difference between 0.68 and 1.7. It's almost 1 meter. It's actually 0.98 meters. Is that correct? 0.92 meters. And that's all in 1 second, roughly. So the answer in this case is 0.92 meters per second. A faster rate. Velocity equals speed, position change over time is just one way that we're going to express these differences. There's also some ways that we rearrange these, and you can determine some other formulas as well. We'll get to those in the next film.